Okay, so I just wanted to do a mind garden about Swift because, as everyone knows, Swift is the best programming language. But in all seriousness,
well,
like every language obviously has its strong points, but I think there's a lot more to Swift than people realize. I think the general perspective on Swift is that it's a programming language for Apple platform development, and that is mostly true right now, but there's other places that Swift is moving towards. And the general goal of the inventor of the language, Chris Latner, is for Swift to take over the world. So currently, strongest point in Swift is obviously Apple platform development. Apple has put a lot of resources into developing the language. The second strongest point in Swift right now is probably server-side development. There's a really good framework called Vapor that you can make a production-ready web server with. And slowly but surely, Swift is expanding to other platforms. It runs on Linux. Last year, there's an official toolchain for Windows. There's currently an unofficial toolchain for Android, and so I think Swift has a bright future on other platforms as well. Just as a brief history of how Swift came to be, Swift started as, I think, a graduate project for Chris Latner in 2010. And in a podcast I listened to, they asked him, like, why did you try to invent a programming language? Didn't you realize how hard that is? And he just responded yeah, I had no idea that you're not supposed to invent an entire new programming language. He's just he kind of just started doing it, and it turned into Swift. It was picked up by Apple, and he started working on it with a larger group of people, and it was released in 2014 with a 1.0 version, and ever since then, it's they've just continued to work on it and adding all the features that Chris Latner dreamed that it would have. One cool thing about Swift, because it is a programming language that is fairly young compared to some others, is it has taken ideas from a lot of different programming languages, including Objective-C, Rust, Haskell, Ruby, Python, C#, and really pretty much any programming language that has a good idea, Swift tries to incorporate into its syntax and runtime. So I might talk more about some specific Swift features in the future more in detail, but today I wanted to just go over kind of a hodgepodge of points that I think are really cool about Swift that make it unique, that I think most other programming languages, or sometimes not no other programming language uses. Actually, one more let's just dive into that. So the first thing that I think makes Swift a really strong multi-purpose language is its runtime model for automatic memory management. So pretty much every language that I know of other than Swift that doesn't do manual memory management like C and C++ uses some form of automatic memory management, and usually it comes in the form of garbage collection. And the general algorithm for that is called mark and sweep. Does anyone know how mark and sweep works well enough to describe what it does? Anyone? So Any modern programming language, whether it's like JavaScript, C#, TypeScript, which is obviously just JavaScript, Ruby, they all have a memory management model, and they keep track of the objects that you're using, and they also want to keep track of objects that you're no longer using so that they can reuse that memory. So at a time determined by the language runtime, it's going to check if you're using an object, and if you're not, it's going to deallocate that so you can reuse the memory. So the way that mark and sweep works is it stops the programming execution, and then starting from root objects that are on the stack, it traverses all of the different references, every object that's referenced, and it traverses any objects that are referenced by those objects, and it marks them as being used. And then after it's done marking all the objects as being used, then there may be objects that didn't get marked, and those ones are not being used, and it goes through and deallocates those. So the reason why this is good is because you don't have to worry about allocating memory or deallocating memory and keeping track of where all your objects are going. And that saves programmers a lot of time. The problem with it, though, is it can cause unexpected performance issues. So if the amount of memory allocated to your program is running out and it needs to run garbage collection immediately, it's going to freeze the world, perform it, which could take a long time. It could even take seconds or longer. In the case of a user application, that's really bad because it's going to look like the app froze. In the case of like a server application, it could also be bad because you could have responses that time out. So that's basically how every other language manages memory. What Swift does, and actually Objective-C as well, is called automatic reference counting. And it uses a lighter weight approach that is faster and doesn't have the problem I just described, with one caveat. And so the way automatic reference counting works is anytime you create an object, it's going to also create a reference count for that object and increment it by 1. And then anytime you assign that reference to another space in memory, it will increment it by 1. And then anytime a reference goes out of scope, it decrements it by 1. And so if it's counting the references of each object and the reference ever goes to 0, then it knows immediately it can deallocate the object instead of waiting for a garbage collection time. And so that's good because you never have the problem where the programming runtime freezes to free up memory. And a lot of times it can also be faster because all of this is figured out at compile time instead of garbage collection, which has to be figured out while the program's running. So that is like the first thing that I think makes Swift in a lot of ways better than any other programming language. The other thing that I wanted to do was just kind of go through some Swift features that I find useful, kind of get a sense of like what Swift syntax looks like. How well can the people in the back see that? It might be useful for people to scoot up if you can't. So at this point, it would definitely be probably more constructive if you guys like stop me and ask me questions like, why does Swift do something this way? Or actually, I would be very happy for you to say like, I think that's a weird thing for Swift to do. Like that's, you know,
I'll poke every hole I can.
I'm not sure Swift is such a good language, Roy. Like that's kind of weird or whatever. So.
I don't like how there's no parentheses in the if statement on line 11.
Okay, yeah, we'll get to that. Okay, so the first thing is just like a very simple thing about Swift. Swift is a statically typed language, which means anything that you declare as a variable has a type, and the type doesn't change for the lifetime of that variable. But Swift has a really powerful type checker, and so if I assign a value to a variable, when I declare it, it will infer the type. And if I'm clever about the way I do things, there's a lot of places where you would have to worry about type declaration where you don't in Swift.
Swift have constant types?
Yes, that's a good question. So if I wanted this variable to be constant, I would change the var to a let, and then if I tried to change this to anything else, it would get mad at me.
Oh wow. It's like the exact opposite of JavaScript.
Yeah. JavaScript, the constant is const, and the like.
Let is.
And let is mutable.
Let is mutable, yeah.
Yeah. Okay, so
I guess there's no reason.
that's the first example.
Or just interesting.
Okay, now let's go on to an example of a function definition. So pay attention to this. If this is like a very common like programming challenge for job interviews. So if you ever need another job, actually
Do it in Swift.
just don't actually go get another job. That would be sad. But hopefully most engineers are familiar with like the Fibonacci sequence.
Why on line 16 is the parameter named? Why do you have to like label n colon -1?
Yeah, so that's a great question. So in Swift, parameters are named by default. And I think that's a great quality of Swift because a lot of times when you're passing things to functions, the only easy way to see that you're passing the right thing to the right parameter number is to look up the function definition. But in Swift, all of the parameters are labeled, and so it's a lot easier to see that you pass the right thing to the right parameter.
It doesn't have to be in the same order.
It does have to be in the same order.
Oh, it does?
Yeah.
So you have to name it and preserve
Why
it.
is it named?
Arguably, you still have to look at the function now.
For documentation purposes?
To give us careful time.
It's named for readability. It doesn't have to be named. I think the reason the order has to be the same as well is for interoperability with C and Objective-C.
Are there optional parameters or defaults or default values for parameters?
Yeah, so just real quick, say that you, like in the case of this method, we're designing an API whenever we declare a method. And so in this case, the name actually is kind of verbose, and we don't want the clients of our API to worry about what the parameter name is. You can rename the parameter just like that. And this would be renaming it as having no name, and then you can pass it in without doing the parameter name. Or if I wanted to be more explicit about it, I could say Fibonacci for n, and then it reads more like English in some cases. That's not the best example, but a lot of times you can make the parameter names read more like English by renaming them as prepositions or something, but have a more useful name that makes more sense in the context of the function body. And then you asked about optional parameters. If you wanted optional value, you could put that. And if you want the parameter to be truly optional, then you could assign it to nil as a default value. Or if you wanted it to not be optional but have a default value, you could also just put it there as well.
Yeah, what is a non-optional parameter that has a default value? Like,
A non-optional value. So if I have something like this, then I could call the function without passing anything, and it would call it with 10 for the value of the parameter.
I think we might be overloading optional. Like,
okay.
I think like nullable would probably be a similar concept in other languages as well.
So, okay, that makes sense.
Like when you put the question mark on there, that means it's a int that can be nil, right? It can have a value or nil.
That's right. So when you're talking about Swift, to speak clearly, optional means a value that can be nil.
So if you have that question mark right there, can you call Fibonacci without specifying a parameter?
No. So if I just have that there, I could call it with nil.
Okay.
If I wanted it to be callable without passing a parameter, I'd have to say the default value for this optional int is nil.
Thank you.
Okay, so we got to line 11, where we pointed out that the if statement doesn't have parentheses. That's actually a great feature of Swift, is you don't have to put parentheses around if statements. They're kind of superfluous and you really don't need them. And so that saves, I don't know, like 2 characters per if statement. If
For
you,
lifetime coding, that's like,
yeah,
Let's go to it.
that'll, yeah.
It's pure power.
But you can, if you want.
Yeah, you can if you want.
Will all your Swift teammates get annoyed and relint it and
Yeah, our linter actually checks for that, and we'll tell you to not do that. But yeah, in Swift you can use parentheses for precedence, and so I could put a bunch of parentheses in here if I wanted.
I'm totally gonna go do that.
It'll make it look like a list.
Okay, so this is the part where I tell you, like, in the interview when they ask for like follow-up for like how could you make that function faster or more fancy. So starting with more fancy, Swift has great
It's a
pattern.
definition of fancy.
It has
We're about to find out.
it has great pattern matching, and so this is the code does the same thing, but it just shows that you can use switches not just like in Java where you can only use it for numbers and like strings and a few other things. You can match things against ranges, enumerations. You can even make your own matching overloads to basically match whatever you want in a switch case statement.
What is the ... operator specifically doing?
So this operator is a open range, so it goes basically from -infinity to 0 inclusively. If I wanted to do it not inclusively, I could
Okay.
do this one. So here's an example of using tuples in Swift. Tuples are pretty useful if you want to return multiple values from a function. In this case, I just used it to store the previous and the one before that so that I could iteratively calculate the Fibonacci sequence instead of recursively. So while statements are like ifs, you don't need to have parentheses. And any questions about that?
Is this actually faster?
Yeah, this is faster because the recursive algorithm is going to do a lot of
Rework.
rework.
From the bottom every time.
Where this one is going to just, it'll be linear time.
So on line 28, does the capitalization of that name mean anything?
In,
Var capital N equals 3, is it?
no. Swift is case sensitive, so it was just my way of having another variable name.
I'm interested in line 31, the accessing of the tuple by a dot.
Yeah, so this is unique for tuples. So tuples by default will be accessed kind of by index. You can also do named tuples, so I could call this like this, and then
Could you still do .0 if you wanted with the names?
I think so.
Can the tuple have more than 2 values in it?
Yeah, tuples can have however many. There might be a limit, like
Maybe a 3 one.
27 or something like that. But I'm not sure.
Sorry about
Such a
that.
troll. Such a troll.
Dot tuple. Try tuple.
I'll do
Does Swift have destructuring
It does for tuples.
for tuples? So you could destructure that into x and y. Yeah, you go let x, y equal.
I don't think it necessarily works for the naming of the tuples. I'm pretty sure this works. There was actually a pitch last week for destructuring for tuples and structs. So I honestly don't know where that's going to go, but okay, so here's just a few examples of actually calling the function. So Swift allows you to iterate through sequences of things, and so you can iterate through a range, or you can iterate through a collection that might be an array or a dictionary or a set of things. It looks like Swift Playground's kind of freaked out when I changed monitors, but here we go. So we can actually see
That's kind of cool.
this actually looks different than it did before.
So, like, is that part of the IDE to build that visualization?
So this, what I'm in right now is called Swift Playgrounds. It's just for kind of more trying things out than actual development. So
Yeah, but even then, is it part of Xcode?
yeah. So as part of Xcode, you can also, there's a separate app called Swift Playgrounds that does pretty much the same thing. So, okay, so let's see. So the next thing I wanted to talk about is optionals in Swift. So Swift isn't the only programming language that does this, but it doesn't allow you to have a null value that's not an optional. And so unless you explicitly tell it to, it's not going to ever have a null reference exception. So here's an example where I created a struct that represents a student, and it has an optional GPA value because maybe the student doesn't have any grades yet. And the GPA struct is represented by a value which is a double. And then I have a computed property that will format the value as a string. So in the case of this computed property, since it only has one line, you can omit the return. And that's true for functions as well. And then we can skip over this. That's just building a formatter for the number. So one cool thing about structs, just to begin with in Swift, is they, by default, will generate an initializer with named parameters. And so without adding any extra boilerplate to this definition, I get an initializer for student that I can pass these values to. Same thing with the GPA. So now I have a student object. It has a GPA value. Let's say that I want to get the string for the GPA. The syntax, if you have an optional and you want to access a member of that optional value, is $dot. And you can chain as many of those as you want, and it unwraps the optional. But even though we unwrapped multiple times, the end result is going to be just an optional. It won't be an optional of an optional. It kind of does all of that thinking for you and unwraps so that it's always just an optional. So at the end of this operation, I get the GPA, that's an optional. On that, I get the string value, that's an optional. And I want to append like an extra piece to that. So the result of that is an optional. And if I want to kind of have a default value, if it does end up being an optional, I can coalesce it and add kind of like a default value there.
So that double question mark takes an optional and a type and returns an optional?
So the double question mark will take an optional and the same type that the optional stores and return the type. So this is no longer an
return
optional.
the type, so that was no longer optional. Okay.
Kind of like an or.
Yeah.
This
Like,
is,
so it's an unwrapping with a default value kind of.
Yeah, so
so if any of those optionals are nulls, then it'll return null there,
No GPA.
which then says, let's return no GPA.
I believe, I know of at least like, I think JavaScript added that. Ruby has something similar. But one thing that Swift has over them is if you don't do the question marks, the code won't even compile. Because it knows GPA is an optional value. It doesn't have to guess whether it might be null or not. It knows at compile time, this is a value that could be null, you can't just access it for free. If you know, because you checked somewhere before that it isn't optional, it is optional, but you know that it's not null and you don't want to check or worry about it, you can add exclamation points. And so this is still a safe operation to do, but if the value does end up being null at runtime, then it will crash. So another thing that's interesting about Swift structs is it implements a type of object that a lot of programming languages don't offer. They act as value types. So if you assign a struct to another struct, instead of copying a reference to an object, it's actually copying all of the values. So that can alleviate a lot of beginner programmer errors, but
Is it a deep copy?
yeah, well, it is a deep copy if there's structures of structures of structures. You can put a class inside a struct. So if you put a class inside a struct, it would copy the pointer to the class. And so it wouldn't do a deep copy of any class that was within a struct.
Does it aggressively copy when you copy the reference, or does it do a copy on write?
So by default, it does an aggressive copy on structs. I'll talk about arrays in a second, which does copy on write. So if I have a student 2 and I assign it to my first student object and I change the values, I can look, student 1 didn't change even though I changed the values on student 2, and that would be different if it was implemented as a class. And so for most cases in Swift, we default to using structs, other than this like simple scenario that an experienced programmer wouldn't run into as often. It also means there can't be data races, because when you're passing values around, it's always a copy. You don't have to worry about 2 different threads accessing the same memory at the same time, because each thread has its own copy of the data. One thing that you might be worried about is what if I have a huge structure, right, that has a lot of data. I don't want to copy it every time I pass it to a function or assign it to a new variable. There's a few ways that you can alleviate that in Swift, if you really need to, which most of the time you don't. One is you could just change the struct into a class, and then you get reference semantics, which is what you're used to in most other programming languages. Another thing that you can do is you can implement copy on write in your structs manually. Or you can use a Swift container. So if you're using a Swift array, a Swift dictionary, or a Swift set, it still follows value semantics. So if I have array 1, I assign it to array 2, and I append something to it, the 2 arrays are still, they're different. But say I just have this array 1 and I'm passing it around, it follows copy on write. So it's internally not going to copy the memory in the array, but if anything tries to mutate something in the array, then it's going to make a copy at that point.
Do you know if it's like doing anything? Is it making a full copy of the array, or is it like doing something clever, like a lot of languages will have immutable arrays, and they'll layer basically diffs on top of the arrays as you add to them.
Yeah, so I don't know the exact.
Shenanigans or?
I don't know the exact details of that per se. I think in this case where I'm appending something, it would try not to make a copy. If I did something like changed something that was in the previous array, I think it would make a full copy.
Got it.
It's kind of annoying. Right?
It's probably not that annoying because it's not a very common use case actually to.
Like if I have like a backend process that has like a massive array, right? Like that, and I just want to take one thing. Is that Like, am I thinking about this wrong, I guess?
Maybe not. So it is something that you have to think about. It's kind of like a different way of thinking about arrays that usually makes things easier and safer to handle, but might sometimes run into problems like that where you want to think about it a little bit more. Okay, so another thing that I think is really cool about Switch is the error handling is as performant as a jump statement. So that's not true in most languages. So like in C++, if you throw an error, it has to traverse the call stack until something catches it. Or same in Java, and I think most other languages. In Swift, and so in other languages, you really only want to throw errors for something that's truly going to kind of destroy the process of what you're trying to do. As far as designing code, that's probably still true in Swift, but you don't have to worry about it. You could use exceptions as control flow if you want to, or if it's convenient. So here's another implementation. The only difference is really the Fibonacci sequence doesn't exist for 0 and lower, so I'm just going to throw an error. And what error handling looks like in Swift is, first of all, you can't throw an error unless you mark a method as saying it throws, and that tells the compiler enough information that it can figure out how to create the correct jumps. And then when you call a method that's marked as throws, you have to put a try in front of it. And then you can catch the error, which is very similar to languages like C++ or Java. The difference is, though, that in C++ or Java, doing this sort of thing would be a bad idea because every time it throws an error, it's going to slow down the program, where in Swift, it will jump directly to where it needs to if the error is thrown. Actually, funny story, the first job I got, they had a programming challenge, and I was naive and thought I wanted to just show that I knew how to do different things in C++. And so I implemented bounds checking by throwing an error. I submitted the code, and it didn't run within the allotted time they gave for the test cases, and they almost didn't pass me because I used error handling as a way to return from a function if it was out of bounds, and it slowed the function. It slowed it down too much, but that wouldn't have been a problem if I was using Swift. So another cool thing about Swift is it has a powerful, much more powerful enumerations. And one thing that you can do with enumerations is give them associated values. So here's an example. I have two different types of people. I have students and I have teachers, and maybe I want to store them in a collection together. Instead of maybe creating a class hierarchy where both of them inherit from person, I could create an enumeration, and if it's a student, there's an associated value that is a student object. If it's a teacher, there's an associated value that's a teacher object. So here I create a teacher object, and now I'm going to create a collection that contains people, which could be either students or teachers. And right here, when I'm declaring the variable, I actually do want to declare that this is going to be an array of persons. And the reason why is because Swift allows you to implicitly look up members of objects. And so since there is a person type dot student available, instead of explicitly saying this is a person dot student, Swift knows that this is a person array, and so when I do dot, it's going to look for anything that's accessible on that struct, class, or enumeration, and you can do that without specifying the type in front of that. And then this is a student case for the enumeration, and it has an associated value that's stored in there. So the first one I pass in student, the second one is a student with a student2 object, and the third one is a teacher with a teacher object in it. And so here's an example of iterating through the array of people. So this is the same syntax as before, but instead of iterating through a range, I'm iterating through a collection. And I'm going to do a switch on the person, just like you would do with an enumeration in another language. But since there's an associated value, I can bind it to a variable when I'm doing the case statement. And then once it's bound to a variable, I can do whatever I want with it in the body of the case. One more note on switch statements actually in Swift that I'll go through is Swift requires you to have exhaustive switch statements so that you don't forget about something in enumeration. That's really useful if you go back, say, and like add a third type of person. Then it would alert you, you're using this enumeration in a switch statement somewhere completely different in the code, and you need to add that as well. So that was kind of a contrived example of how you could use associated values in enumerations. One that I'm actually, here's a way that you could use it in a more useful way. So say you have a resource that's part of a view model. It could be a resource of any type. That's what this generic parameter is here. But you could use an enumeration to store what state the resource is in. So maybe the current state is that the resource is unfetched, or maybe the current state is that it's loading, and then the UI would know to show a loading spinner. Or after it's done being fetched, you could set it to sum with an associated value in there that's the type of the resource that you fetched. And here's an example of how you would use that in code. So say I had a resource that was an array of the person object. Maybe I want to default it to be unfetched, and then later in the code I would fetch it and set it to the new value. And that's all I have. Is there any, we could go over any questions you have about Swift or anything I said?
Just general, if Apple's so involved in the development of it, I did a couple of Google searches, and everything that I saw was like Apple resources and things. Are there examples of other people currently using it?
Yeah, so I think the biggest example of like a big enterprise company using Swift outside of Apple platforms is Vapor. So Vapor is a web server. It runs on Linux. So you can actually develop it on Mac. You can run it in Docker. Probably the most popular form to deploy it to a server is through a Docker container, but you could also deploy it directly to Linux. There's a pretty good ecosystem of packages, including templating libraries for HTML, database drivers, and of course, like the API layer for API endpoints.
Have you actually run the web server?
Yeah.
It's not vaporware?
Bam.
And
That'd be a great troll, wouldn't it? To name a product vapor that they never come out.
And there's a few companies that are actually using it to make money. So here's an example of a few of them. There was another big back-end framework called Kitura that IBM was sponsoring for a long time, but they dropped it. So this is like the biggest one.
Who approves changes to the language?
Vapor has a standard image on Docker Hub.
If you wanted to know that,
You can start rewriting payments in the best
I guess
language.
I'm curious to know if basically if Apple has complete control over it, or if there's like, or if there's a larger community, you know?
so Apple has a large influence over it. And like at the end of the day, as it currently stands, if Apple wants something to happen in the language, it's pretty much going to happen.
Okay.
But they do do a pretty good job at involving the whole Swift community. There's a Swift on the server working group that also has a lot of influence. Chris Lattner actually gave up control of the language to someone working at Apple and went over to work for Google. And he worked on this huge project for Swift for TensorFlow. And that project actually had a lot of influence on Swift language features that made the language better as well, that really would have never come from Apple as well. So there are like other perspectives that add things to the language outside of Apple.
What is Swift like? So I'm a little fuzzy on compilers here. What compiles Swift and what does it compile to? Like, what does that artifact look like?
So Swift has a multi-layered compilation process. It actually has two intermediary languages. Swift first compiles to a specialized Swift intermediary language, which it uses to perform Swift-specific optimizations. And then it takes the output of those optimizations and compiles it to LLVM code. And then it runs LLVM optimizations on that before it outputs a binary. So that's great because LLVM supports a lot of architectures. So like anything that LLVM supports, Swift could support. And that's the same thing that actually Rust and C# target as well.
So dumb question here, why can't I develop Swift on my Linux?
You can.
Yeah, you can.
Oh.
Yeah.
But I have to use Docker?
No.
You don't have to use Docker at all.
Great.
There's some libraries like Foundation and there's some libraries that are like you have to use different libraries. So part of the thing that is still in the process of being worked on, depending on your operating system, it's at a different stage, is like library support for Swift. So for Linux, all of the foundational libraries are there. For Windows, a lot of them are there, but not as much as Linux. And so, yeah.
It's like because like there's just Mac dependencies,
Uh,
Mac assumptions baked into the other libraries.
Yeah, so like in Foundation, for example, there are like operating specific calls. And so those have to be rewritten to work on Linux.
So it sounds like it doesn't have a runtime, going back to the previous question. Is that right?
Swift does have a runtime.
Does it just statically link it with the LLVM?
So I
Output.
actually read about this just barely. There's like a core lib that's specifically written for Linux. Or I don't know if that answers your question, but Yeah, it statically links the runtime,
I don't understand what that means.
I think.
It's like not a VM,
Yeah, there's not a
Okay.
virtual
Okay.
machine like
but it does have
Java.
a runtime.
It has a runtime. I actually don't know everything that the runtime does because Arc is done at compile time. One thing that I know that it's going to do in the future is they just added a language feature for async await, and the runtime is going to handle some
Like
of the
trackable.
asynchronous support for that.
So since JavaScript had async await before Swift, then isn't JavaScript better?
No. I'll probably actually do an entire separate talk about async and await in Swift because it's the best implementation in any language out there. I just thought maybe
You're
I would.
consistent, Roy, I love that.
I would maybe just kind of egg you guys on a little bit more. I made a tier list of programming languages that I have professional or at least academic experience in. So Swift is obviously the only S tier language.
Us being Swift, right?
S being super awesome. Then there's Rust, Julia, C# and Python get a B.
Is F fail? Is that?
Can you title this the completely objective and unbiased?
And
Scala's below C#.
Scala is a really good language. The problem that I know about because I worked at Lucid is that the people in charge of it are purely academic people and they don't care about problems with the language that affect production. And so like Lucid has reached out to them and say, this is a problem with the language, we need to fix it. And they're like, I don't care, basically. So I think Swift has, Scala's been stuck at 2.7 for years, and it doesn't seem like 3.0 is ever going to come out. So, great language, but I don't know if it has a future. That's why I got a C instead of a B. Lua would be higher, except for arrays start at 1 instead of 0.
That's fair.
But it's actually a really cool language because it's an interpreted language, and the interpreter is really small, and so you can port it to a platform really easily. You just have to take the C code that writes the interpreter and compile it for the platform you want. I learned a little bit of PHP, but I never used it because I never wanted to.
Cool.
Where does Go go on?
Go, I wanted to put on there, but I actually don't have experience with it. So,
This is a list for experience. And those
um,
Kotlin's not on there either.
also I think it's a good language, but I don't have experience with it, unfortunately. I had this channel at my previous job. So you don't have to join today, but if you ever come across something really stupid in a language, like Kirkby did last week, feel free to post it here and explain why the language sucks. If you come across anything in Swift, you can post it here so that I can tell you why you're wrong.
Thanks, Roy.
I'm convinced.